welcome to your next challenge in the LeetCode Easy series. You'll notice it says number 7, but it's actually the second problem. If you go to the problems and then filter by easy, you'll see it's second in the list. Anyway, given a 32-bit signed integer, reverse the digits of an integer. Check the examples. 123 goes to 321, negative 123 goes to negative 321. And this is a nice example too. 120 goes to 21 with the idea that the 0 would be in front, but we don't print leading 0, so it's just 21. There is a note. Assume we are dealing with an environment which could only store integers within the 32-bit signed integer range, and they provide the inclusive range negative 2 to the 31st to 2 to the 31st minus 1. For the purpose of this problem, assume that your function returns 0 when the reversed integer overflows. Okay. So I should say, definitely give this a run yourself. Try and come up with your own solution first, and then feel free to proceed with this video. So the first way to do this that kind of pops into mind right away would be to convert the convert the integer to a string, maybe a character array. With the array, you can call reverse. We know arrays have a reverse method, and then sort of use that to get the digits reversed, and then handle exception overflowing along the way and get the result that way. So I'll probably do that first. Not sure that it's the best way, but it's a way. First thing I want to do is note if the input is negative or not. That's a special case. You can imagine if I have a negative 1, 2, 3 and I convert these to characters and reverse them, I might get something like 3, 2, 1 minus, and I want to take the negative sign out of it to start, and then we'll put it back on at the end as necessary. So that would simply be if x is less than 0. We know it's negative. Then I'm going to make a general try block here, because there are, if any point during our processing, if something goes wrong, we want to catch that and handle it. So they made it simple here. Just simply return 0 if something goes wrong. Then I'm going to grab the magnitude. Again, I want to get rid of the negative concept for now. And we know that the math class has this ABS, absolute value function. If I take the absolute value of x, that gives me sort of the magnitude value. So if I had negative 123, now I'm just dealing with the 123, which is good. Then I can convert this to a string. And strings are underneath it, they're a collection of chars. So I can treat that enumerable collection, and I can convert it to an array of chars. So this it had a number, it made it into a string. Now from the string, I've turned it into an array of characters. And let's just make a variable here to hold that. Char array. Just call it digit chars. That works. Now, because it is an array, the array class has a reverse method that I can call on digit chars, and that will rearrange them so they go from 1, 2, 3, for example, to 3, 2, 1. That will handle that portion of the problem for us. And then finally, I want to take this reversed character array, turn it back into a string, and we know that the string class has a constructor that will take a character array to make a string out of it. So I can say digit chars. This will give me the new string that I want. And then the int32 class has a parse method where we can sort of extract the number value from a string, provided the string is actually a number. And I believe it throws exceptions otherwise. So we have that. Let's just store this in a local variable. So that's our result. And then now we got it back into number form after reversing it. That's great. But remember, we had this negative thing that we should be concerned about. So let's say return is negative. We'll use the ternary operator here. If it is negative, we want result times -1. That will convert it back. That will put that negative sign in. Otherwise, simply return the result. Okay. I think that looks good. I can probably give this a run. Let's see if I did anything stupid. Okay, I liked the 1, 2, 3 example. I think there's a way you can put in your own. Maybe not. I thought I could adjust these values and run tests on other values. That's fine, I'll just submit it. Okay, successfully submitted. And this turned out to actually be a lot faster than a lot of the online submissions. Okay, that's cool. Not stellar for the memory usage, but a lot of times that's not a problem at all. So there was another way you may have gone about this problem. You could do it without converting into strings and characters. Why not go through that as well? So I think the concept of this is the same as far as being aware of this negative possibility, working with the absolute value. So I might make a helper method that can, let's go private, and let's call it, what I'll do is I'll take a number as an input, let's call it num2 reversed digits, and it will take a number as a parameter. And the idea here is that we'll go through and sort of strip digits off and construct a list from it. And then we'll use the list that's generated later on to sort of go back to sort of get the final integer value. We can do that. So I can get rid of this. We're going to go in a different direction for this other implementation. So let's implement the helper method. First, let's start by making a list, a new list. We'll call it digits equals new list type int, right? Now, while n is greater than 0, we're going to sort of pull off digits one at a time. And if you can think of a way to do that, the modulo operator is quite handy. We could say something like int digit equals n modulo 10. So what this would do, remember the modulo operator gives you the remainder of a division operation. So if you had 123, you go modulo 10. 123 divided by 10 is going to go to 12 in integers with a remainder of 3. and so it gives us that 3. So you can think of it like peeling off the least significant digit from the number, which is, you know, what we want for building this list. So I can say digits, add digit, and then we got to update n so we don't loop forever, right? That would be bad. So then we can say n divide equals 10. That's the same as n equals n divided by 10. And that will bring that number down to 12 for the next iteration. Remember we said 123 divided by 10 would be that 12 remainder 3. Well, this will discard the remainder because it's an integer, and then it'll be 12 for next time through the loop. We'll come back in, n is 12. It'll go n modulo 10 will be 1 with a remainder of 2, so digits 2. You add the 2, and the process continues again. N goes down to 1, and yeah. So that's how that works. Then we can, that will help us. We can say list of int reversed digits equals num2 reversed digits magnitude, right? And then we're going to want to sort of extract a value from these digits. And we can, if we're clever about it, we don't even have to change the ordering of the digits like we did in the first problem. So we should make another helper method for that. Let's call it something like private. It's going to return an integer. This is the answer we want. Get value from digits. And that should take in a list digits. Okay. That's what we'll feed this into this new method. And so the idea here is we'll make a sort of a variable here, local variable, to sort of accumulate the sum of, we're basically going to multiply each digit by its appropriate weight. So if you can think of a number like 123, 3 would be the ones place, right? 2 would be the tens place, 1 would be the hundreds place. If you had a larger number, there'd be a thousands place, etc. And so if you're familiar with binary numbering systems, you've probably looked at that each place can be looked at as the base to a power. By that I mean the ones place is 10 to the 0 power, right? And the tens place is 10 to the 1 power, and the hundreds place is 10 to the second power. And so we can use that to weight the digits accordingly and do it in a way that supports reversing the number, get a value for the number reversed. So let's make a little num digits count. That'll be a nice little I is less than num digits, increment I. Then, since we're going to be adding potentially very large numbers here, I think I should wrap it all a try catch block. And then if something goes wrong, I think I'm going to use, because at this point I should have all positive numbers. I took the absolute value. So I'm going to use this return -1 is kind of going to be my signal, like, hey, something went very wrong here, and then the calling function can do something appropriate for that. So how do we make this sum add properly? Each time through, you can imagine we're going to add something. So we're going to take the digit in question. That would be digits I, right? Whatever we're at in the loop. And then, like I said, for each of those places, it's 10 to the place power, right? So we're going to multiply it by its weight. In this case, we know that the math class has this power function, or pow, for calculating powers. You list the base first, and we're in the decimal system. We're going to remember those integers were passed to us that way. Base 10 is the first argument. Then the exponent comes in the second argument to that function. So, and one thing to note is that the power function returns as a double, so I can cast this back to an int. I don't know if they'll give me double. Yeah, it'll probably complain that I might be losing precision, so I'll just cast it to an integer to match the type of this. So, how do we do the powers? 1, 2, 3 should be 3, 2, 1, for example, in a reversal. So for the first number, we want the highest weight for number to reverse. Yeah, actually, because our list is in reversed order. We reversed it right here. Remember, we were peeling off the least significant number at a time, so 3 got added first, then 2, then 1. So we already have it in the reversed order. So, okay, cool, I'm good there. So then we need to raise it to the appropriate power, and it's going to have to do with num digits, right? The size of this minus 1. Think in the example of 1, 2, 3, right? It's going to have 3 digits, but our biggest weight in there is going to be 10 to the second power, right? It was 0 numbering. 0, 1, and 2 are 10 to the 0, 10 to the 1, 10 squared. So num digits minus 1 is going to get, you know, that 3 minus 1 is 2. And then we can say minus I, the index we're on. It'll be 0 the first time, so it's like it doesn't even factor in. You'll get that 10 to the 2 that you want. But on iteration where it gets incremented to 1, then this will go to number of digits minus 1, which will be the first power, which is what you want in the tens place, 10 to the 1. And then this will get incremented to 2. It'll come through, it'll say num digits minus 1, minus 2, and that'll be 0. 10 to the 0 is 1. You'll multiply that value by 1. So that looks good to me. I think that should work out. Yeah. We'll see if they give me a hard time about casting this second argument as a double. It's supposed to go in as a double. We'll see. I'll try running it. Anyway, so that helper function was quite nice. This did reverse the digits. We peeled off the least significant numbers first, constructed a list out of it, and then we're sort of grabbing each value in the list and multiplying it by an appropriate weight to get the value of the reversed integer. So we can use the reversed digits field as the input to let's call it result equals, I'm just going to copy the function name there. We can pass in reversed digits. Okay. Now remember, if something goes haywire here, we were going to get a negative value for result. So let's check that. If result is less than 0, something went wrong, right? We were adding positive numbers. It should keep going positive unless it overflows. So they told us in the instructions, if something goes wrong with overflow, return 0. And then we also have that issue like we had in the first implementation where we check if it's negative. If is negative, we should multiply the result by -1. And we could also write this out in the ternary way like we did in the first example, whatever you like. And then I think at this point we can return the result. So, I think that does it. Yeah, reverse the digits, multiply them by their weights. The weights get applied to the reverse digits, so it works out. Okay. Let's run it with the example. See what it does. Code, assignment, error. What's that call it? Oh, sure. You see what I did there? If you want, you can pause and figure it out. It should be result times equals 1. I'm trying to multiply it by -1. This doesn't change the value of result, right? It's just a meaningless statement. It's just kind of a throwaway thing. So thank you, compiler. This is what I want. Cannot implicit. Yeah, okay. So I was a little bit worried about that. That's nice they highlight it for you in here. Okay, let's convert this into a double. See, we made the 10 into a double, but it's supposed to be 2 double parameters. Let's see if that appeases the gods. Nope. Let's see what I do now. Oh, sure. I want to take this whole thing. Get value. Not all code paths return a value. Get value from digits. What did I do there? Oh, sure. Yeah. Oh, I'm just on fire today, aren't I? So do you see what I did here? I definitely did not. We've been building up this sum variable, and that's wonderful, and then I don't even return it. Yikes. Let's return that instead of throwing all of our work away. Num to reversed digits, not all code paths return a value. Num to reverse digits. And sure enough, look at that. I did the same thing here. You guys are probably yelling at your screen like, return! Sheesh. Okay, so it accepted 1, 2, 3. I thought I could modify these. Anyway, I'll just submit it. They'll run the battery of tests. Okay. So, this is significant, right? We did significantly worse in terms of speed here. So, yeah, I don't even know that it was worth the extra work. I think the other one said faster than 89% of submissions. But you can see they show, oh yeah, okay, so they show me in the log here. Memory is pretty much a wash. Given how short this runtime is, I guess that's significant. So, yeah, something to be seen there. If you have any questions about any of this, feel free to leave them in the comments. If you had a really cool solution, I would love to see it. So, thanks for watching, and I'll see you in the next challenge.